Hello, 8th graders. This video is to show you how to do scientific notation, which is the next ELR of our unit. In this video, I'm going to show you the rules for doing scientific notation and a few examples, as well as some practice problems. All that you need to do is follow along on your paper as we go. Here we go. The first place to start is talking about why we even do scientific notation. So the reason why scientific notation is a thing is because it helps us to deal with really, really large numbers or really, really tiny numbers when we're writing them down. So I've got two examples for you. Let's say that we wanted to talk about the mass of the sun. Let's say you're writing a paper and you need to refer to this number a whole bunch of times. Well, the mass of the sun in kilograms is that giant number with all the zeros in this middle of your screen right here. And this would be really, really tiresome to write a whole bunch of times. So scientific notation helps us to shrink that down, but still talk about the same number. Same thing works with really, really tiny things. I'm a chemistry fan, and in chemistry, you have to talk about how big atoms are, especially if you want to talk about how they bond to each other and make new things. You have to talk about how they fit together, and that has to do with size. Well, the size of an atom is this teeny tiny number in meters, and that's just really hard to write over and over again, so we use scientific notation. Let's get into it. For your quick notes, there are a few things that you need to know. Scientific notation is used when numbers are either really, really big or really, really small. And each part of scientific notation, this is an example of that right here on your screen, has a name. And so throughout this little short video, I'm going to be referring to each part of the way we write scientific notation using their name. We're going to start with this 8.39 part. This part out in front has a name, and it is called the mantissa. I would love to know where that name comes from because it's very fun to say, the mantissa. The next part where it says times 10, this is called our base. There are actually a lot of different types of ways to do scientific notations. You maybe have heard of some of them. We use base 10 most of the time, that's why it's a 10. But you could substitute this number with an 8. Actually, computers talk with a number 8 right here, or a 2. Some computers also talk in binary, so they've got a 2 there. So there are a lot of different numbers you can put as your base. The last one, where the 5 is, that's called our exponent. So each one of these different parts of scientific notation is actually an instruction. They tell us how to translate this into the actual number that we're talking about. So that's what we're going to do with the rest of our video. I'm going to show you how each part, the mantissa, the base, and the exponent, how it shows us what that actually means for a normal looking number. And we're going to be able to translate back and forth from scientific to regular and back and forth. So let's give that a shot. Let's start by converting a really big number into scientific notation. I've got these steps on your screen here, and we're going to follow them one at a time in order to get this thing converted into scientific. First thing that we have to do is find the first non-zero number. So literally what you're going to do is you're going to start on the left side and work your way over until you get to the very first non-zero, or something that isn't zero, number. And it looks like our first is a 4. Not super complicated, but never start with a 0. You'll see why when we get to some numbers that are really small. When we do those, you'll see why we start that way. Step 2, we need to count how many spaces the decimal has to move in order to get in between our first number and our second number. So we are literally going to start with where our decimal is. Remember back to when we did metric. It's here at the end. And we need to count how many little spots that decimal has to move over in order to get in between our first number and our second number right there. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots that thing had to move over. And that tells us something when we are writing up our notation. All right, the last spot, and this should actually sound a lot like scientific or like metric system so far. When we're doing scientific notation, there's a positive exponent and sometimes there's a negative exponent. Positive exponents mean really, really big numbers, and negative exponents mean really, really small numbers. A lot of times people get sort of confused and they think that positive exponents mean positive numbers and negative exponents mean negative numbers, and that is not true. If you have a highlighter, step 3 is the biggest place where people make missteps. You may want to highlight that one. So since we're dealing with a really, really big number, we are definitely dealing with positive exponents. Oops, that's not the color want positive exponents. All right, last step, leave no more than 2 or 3 numbers after the decimal and round as necessary. So here's what that means. That's easier to just say. So since we moved our decimal down here in between the 4 and the 0, in this class, we're always going to just use 3 numbers to talk about scientific notation. So we're going to have 4.02 is what we get after we moved that decimal all the way down. And all those other numbers that came after that, we're basically just rounding them off. We're saying this number is so big that this 6, the 0, the 7, the 9, the 3, the 4, all of those numbers, they're so insignificant compared to the size of this huge number that we can just round them away and it's fine. So we've got 4.02, but here's the thing, there's a 6 in this next spot over. And so what we have to do is we have to round up. So I'm going to get rid of our 2. We have to round that to a 4.03 since the 6 makes things round up. All right, now we've got our base. Every single time in this class, we're doing base 10. When you get further in math, you'll learn about how it makes it different to do other bases, but every single time our base is going to be 10 in this class. And then the next and the last part is our exponent. The exponent tells you how many times you moved your decimal place. And if it's positive, it tells you that you made a really big number, and if it's negative, you made a really small number, just like we talked about from step 3. So we had to go 11 spaces. That means that we're going to go a positive 11. And now we've converted this really giant number into 4.03 times 10 to the 11th power, and that's our scientific notation. All right, let's try something different. Let's try some negative exponent. First things first, negative exponents are for small numbers, not negative numbers. I'm going to say it a bunch of times because it's a pretty common mistake that people make. So here's an example. We have 5.76 times 10 to the minus 4th. A lot of people are like, oh, minus 4th, that must mean we have a negative number. No, no, no. If you had a negative number, the negative sign would be out front, like this. That would make that a negative number if I put a negative sign in front of it. But this is not a negative number. It's just a really small number. It has a to the negative 4th power. So let's convert that back into normal notation. The steps for that are kind of like going in reverse. So we're going to figure out if our decimal is going to go to the left or to the right. If we have a negative decimal, we need to make a really small number. You have to ask yourself, should I move this thing to the left to make it smaller? Or if I move it to the right, will it make it smaller? Well, if we go to the right, it's going to start turning into 57.6 and then 576. And that would be a big number. So we have to go to the left on this guy in order to make it a small number. Step 2, move the decimal as many places as the exponent says. So it says to the minus 4, so we're going to move 4 spots. So when we do that, we're going to go 1, 2, 3, 4, and we're going to end up with 3 little swooshes that don't have numbers in them. And I bet you can guess what's going to go there. And if you're guessing zeros, you are exactly right. So we're going to have a decimal with 3 zeros and then our number, 5, 7, 6. So we've used our exponent to tell us how many spots we're going to move it over. And actually, we just did number 3 also. And our number is 0.000576. That's a very tiny number. That's what we were expecting because it's a negative exponent. The next thing on your paper looks like this, where it says partner 1 and partner 2. I've explained this in class before, but it bears repeating. If you can convince somebody using your language that you know and understand the steps for a process, that's the most helpful thing you can do to help your learning. So I'm going to ask you and your partners, the person sitting next to you, to go through each of these and take turns. So partner 1, you're going to start on this one, and I need you to use your words and speak, talk about the steps as your partner listens and helps you if you need it. And then partner 2, you're up. You're going to try this one, and you're going to go back and forth and try all 6 of these. When you're ready, please go up to the front of the room and check your answers. After you have checked your answers, if everything looks okay, you're going to move on to the next step, which is making a 4 square. Here's what you're going to do for that. For the 4 square, you need to make your own example. And I need you to show me that you can do this in 4 different ways. So in the very first box, you're going to show me with really big numbers. You're going to make up a scientific notation. and turn it into standard notation. So start with something with a big positive exponent. And then the next box over, you're going to do the same thing, but you're going to go from standard into scientific. So make something with a whole bunch of zeros and show me how you would turn it into scientific. And then do the exact same thing underneath for really small numbers.